Hello everyone, welcome back to the channel. I'm Eric, the workplace safety guy, and today we're diving into a topic that for me is the backbone of safety in any work environment: the protection of our hands. You know, it's easy to underestimate the complexity behind a simple pair of gloves. But the truth is, to ensure our hands, these incredible tools, are truly safe, there's a universe of standards and guidelines we need to understand. And today, we're going to unveil the two major references in the United States: OSHA and ANSI ISEA 105. Get ready, because the journey will be deep and revealing. First, let's get to the basics. What is OSHA? The acronym stands for Occupational Safety and Health Administration. Founded in 1970, OSHA has a clear and vital mission to ensure safe and healthful working conditions for working men and women by setting and enforcing standards and by providing training, outreach, education, and assistance. Although it is a U.S. federal agency, its standards and the philosophy behind them serve as a beacon for occupational safety worldwide. Many safety legislations and practices in other countries, including Brazil, are inspired by or directly influenced by OSHA's guidelines. OSHA is not just a set of rules. It's a commitment to the life and physical integrity of the worker. It places the primary responsibility for safety on the employer, requiring them to identify hazards, implement controls, and provide appropriate personal protective equipment, PPE. And when it comes to hand protection, OSHA is quite specific in its requirements, especially in Standard 29 CFR 1910-138. 29 CFR 1910-138 is the star of our show when we talk about gloves. It is the general industry standard that sets the requirements for the selection and use of hand protection. And what does it say, in essence? That employers must select and require employees to use appropriate hand protection when their hands are exposed to hazards. I've seen firsthand the consequences of not following these guidelines: deep cuts, chemical burns, crushing injuries, accidents that could have been prevented with the right glove. OSHA leaves no room for doubt about when this protection is necessary. It lists a series of hazards that justify the use of gloves, and it's crucial for all of us, employers and workers, to know this list by heart. Absorption of harmful substances. Think of solvents, oils, chemicals that can be absorbed through the skin, causing everything from irritations to systemic damage. Severe cuts or lacerations, sharp blades, sheet metal, broken glass. A second of carelessness can result in a disabling injury. Severe abrasions, constant or intense friction with rough surfaces such as concrete, raw wood, or metals. Punctures, nails, needles, splinters, sharp pieces of glass. Small holes that can lead to serious infections. Chemical burns, contact with acids, bases, corrosives. Chemical burns can be devastating and require prolonged treatment. Thermal burns, touching extremely hot surfaces or materials, such as in ovens, welding, or even objects exposed to the sun for too long. Extreme temperatures, hot or cold, working in cold storage rooms with liquid nitrogen or in high-temperature environments. Prolonged exposure can cause frostbite or burns. Electric shocks, contact with energized circuits, one of the most lethal risks in the workplace. Dangerous vibrations. Prolonged use of vibrating tools, such as jackhammers or power saws, which can lead to conditions like hand-arm vibration syndrome. This OSHA list is not exhaustive, but it serves as a robust guide for identifying scenarios where hand protection is indispensable. It's a constant reminder that our hands are at risk at many moments of our workday. Now, OSHA's big insight, and what I consider the starting point for any effective safety program, is hazard assessment. There's no point in just buying any glove that seems good. OSHA requires that the employer and we as conscious workers need to understand exactly what dangers are present in our work environment. It's a systematic and thorough process. Imagine you are responsible for safety in an auto parts factory. You can't simply assume that any glove will do. You need to go to the factory floor, observe each workstation, talk to the operators. What are they handling? Are they metal parts with sharp edges? Is there contact with cutting oils or hydraulic fluids? Are there machines with moving parts that can crush? Or maybe you're an electrician dealing with high voltage. Each scenario requires a different analysis, a magnifying glass on the details. This hazard assessment, according to OSHA, must identify the types of hazards. Are they chemical, mechanical, cuts, abrasions, punctures, crushing, impacts, thermal, hot, cold, flames, electrical, biological, bacteria, viruses, blood, or vibration-related? It's crucial to categorize to know what type of protection to seek. The nature of the task. What exactly is the worker doing? Do they need a lot of dexterity to assemble small parts, or are they carrying heavy and rough objects? Will there be prolonged contact with a chemical product, or just a quick touch? Does the task require them to grip, push, pull, rotate? The frequency and duration of exposure? How long will the hands be exposed to this risk? 1 minute every hour, or 8 hours straight? The duration of exposure is a critical factor for chemical permeation, for example. The body parts exposed, is it just the palm of the hand? Or do the wrist and forearm also need protection, such as when dipping a hand into a liquid tank? OSHA not only requires this assessment, but also that it be documented. This creates a record, a knowledge base that can be reviewed and updated. I always say that safety begins with knowledge. If you don't know what threatens you, how will you protect yourself? OSHA understands this perfectly and places hazard assessment as the cornerstone of hand protection. Without it, glove selection is a shot in the dark. With the hazard assessment in hand, the next step, and perhaps the most crucial, is selecting the appropriate glove. And here, OSHA is emphatic. There is no magic glove that works for everything. The glove must be specific to the risk and the task. It's like choosing the right tool for the job. You don't use a screwdriver to hammer a nail, right? Glove selection is a science, not guesswork. And this is where ANSI ISEA 105, the American Standard for Hand Protection Performance and Classification, comes in. While OSHA tells us what to do, protect hands, ANSI ISEA 105 helps us understand how to do it, providing a standardized system for classifying glove performance against various hazards. It's a consensus standard developed by manufacturers, users, and experts, and is widely accepted as best practice for glove evaluation. Let's look at some examples of gloves and what they're for, always from OSHA's perspective and with the help of ANSI ISEA 105 leather gloves. The classic leather gloves. They're great for protecting against abrasions, light cuts, sparks, and moderate heat. I see them a lot in construction, welding, with specific models for that, and handling rougher materials. ANSI ISEA 105 would classify leather in terms of abrasion resistance, and depending on the type and thickness of the leather, also puncture and cut resistance. But beware, they're not the best option for chemicals or very sharp cuts. OSHA reminds us that protection is always specific. Fabric gloves, cotton, canvas. These are more for dirt, very light abrasions, and preventing splinters. They're common in general assembly work or gardening. ANSI ISEA 105 would classify them with low levels of mechanical protection. For cuts, punctures, or chemicals, the protection is minimal, and OSHA would require a more robust alternative if these risks were present. Metal mesh gloves. When the risk of cutting is really high, such as in the meat processing industry or in jobs with sharp knives, OSHA directs us to metal mesh gloves. They are robust and protect against severe lacerations. ANSI ISEA 105 has specific tests for cut resistance, and these gloves would achieve the highest levels. The downside is that they can be heavy and reduce dexterity a bit, and they don't protect against fine punctures like needles or chemicals. Rubber gloves, latex, nitrile, neoprene, butyl. Here we enter the world of chemical and biological protection. ANSI ISEA 105 has rigorous tests for chemical resistance, measuring permeation time, how long it takes for a chemical to pass through the glove, and degradation, how the chemical affects the glove material. Latex offers a barrier against some mild chemicals and biological risks, but beware of allergies. OSHA requires employers to consider alternatives for workers with latex allergies. Nitrile, my favorite for many scenarios. It's resistant to many chemicals, oils, greases, and has good resistance to punctures and abrasions. It's an excellent alternative for those with latex allergies. ANSI ISEA 105 would classify its resistance to various chemicals. Neoprene, a versatile option with good resistance to a wide range of chemicals, oils, acids, and solvents. Butyl, this is the superhero for gases, vapors, ketones, esters, strong acids, and bases. If you work with these materials, OSHA would say, think butyl. The big lesson here is that chemical resistance varies greatly. OSHA requires the employer to verify the glove's compatibility with the specific chemical, consulting the chemical resistance charts provided by manufacturers, which are usually based on ANSI ISEA 105 tests. You can't take chances. Insulating gloves, dielectric rubber. For electricians, OSHA has a very clear requirement: insulating gloves. They are designed to protect against electric shocks. Here, in addition to OSHA, NFPA 70E comes into play, the standard for electrical safety in the workplace, which details the requirements for insulating gloves. These gloves are classified by class, W0, 0, 1, 2, 3, 4, according to the maximum voltage they can withstand. But they have a but. They need to be inspected and tested regularly. NFPA 70E specifies the frequency, and generally they are worn with a leather glove over them for mechanical protection, as the insulating glove alone does not protect against cuts or punctures. OSHA and NFPA 70E are unanimous. Never use insulating gloves without external mechanical protection, unless the task is very low voltage and without mechanical risk. Cut-resistant gloves, Kevlar, Dyneema, HPPE. If you handle sheet metal, glass, or any material with sharp edges, OSHA advises gloves made with high cut-resistant materials, such as Kevlar or Dyneema. ANSI ISEA 105 is fundamental here, as it classifies cut resistance into levels, A1 to A9, based on the force in grams required to cut the material. It's crucial to choose the appropriate level for the risk. An A9 glove offers much more protection than an A3. Thermal gloves, insulated. For those who work in ovens, cold storage rooms, or handle very hot or frozen materials, OSHA requires thermal gloves. They are insulated to protect against extreme temperatures. ANSI ISEA 105 also has classifications for heat and cold resistance. The challenge here is that they can be a bit bulky, which can reduce dexterity. Do you see how complex the choice is? OSHA doesn't give you the ready-made answer, but it gives you the path. Assess the risk, and only then select the glove that truly offers the necessary protection, using ANSI ISEA 105 classifications as a reliable guide. It's a process of safety engineering, not guesswork. The employer must consult manufacturers, safety data sheets, SDS for chemicals, and glove performance charts to make the correct choice. OSHA knows that it's not enough to provide the right glove. The worker needs to know how to use it correctly. Therefore, one of the most important pillars of the standard is worker training. And I, as someone who values safety, fully agree. Knowledge is power, especially when it comes to protecting one's own life and that of colleagues. The employer is required to provide comprehensive and understandable training to every employee who needs to use hand protection. And this training is not a one-time event. It must be repeated whenever there are changes in tasks, risks, or types of gloves used. The training must cover, at a minimum, when hand protection is necessary. It's not about wearing gloves all the time, but during moments of risk identified in the assessment. The worker needs to understand the why behind the use. What type of glove is necessary? Explain why that specific glove was chosen for that task and for that risk. Why nitrile and not latex for that chemical? Why an A5 glove and not an A2 for that cut? How to inspect gloves to ensure they are not damaged. Teach how to visually and tactilely check for cuts, holes, tears, discoloration, hardening, cracks, or any other sign of degradation before each use. For electrical gloves, inspection is even more rigorous, including an air test. How to put on and remove gloves correctly. It seems simple, but for chemical or biological gloves, incorrect removal can lead to contamination of the worker's own skin or the environment. There are specific techniques to avoid this. The limitations of gloves. It's fundamental to know what the glove doesn't protect against. A cut-resistant glove may not protect against punctures. A chemical glove may have a limited permeation time. The worker needs to be aware of these limitations to avoid a false sense of security. Proper maintenance and disposal of gloves, how to clean, store, and when to discard a glove. Some gloves can be washed and reused, others are single-use. The disposal of gloves contaminated with hazardous chemicals or biological substances also has specific procedures. OSHA requires the employer to certify that each employee has received and understood the training. This is usually done through a record signed by the employee. I always say the best glove in the world is useless if not used correctly, and training is the key to that. OSHA leaves no room for doubt. The worker needs to be competent and aware of their responsibility for their own safety. And speaking of correct use and responsibility, OSHA also addresses the maintenance and replacement of gloves. A glove is not a lifetime item. It has a lifespan, and that lifespan can be quite short depending on the use, the environment, and the risks. The effectiveness of protection directly depends on the integrity of the glove. Gloves must be kept clean, dry, and in good condition. Proper storage is crucial. Gloves exposed to direct sunlight, excessive heat, or chemicals can degrade even without use. Before each use, inspection is mandatory. I, for example, always take a quick look. Is there a cut, a tiny hole, any discoloration indicating material degradation? Is it stiff or sticky? If so, the glove must be replaced immediately. It's not worth risking a serious injury because of an old or damaged glove. OSHA is clear. Damaged or contaminated gloves must be replaced. For chemical gloves, the situation is even more critical. OSHA reminds us that the service life can be limited by the permeation of the chemical through the glove material, even if there are no visible damages. In other words, the chemical might be passing through the glove without you noticing, exposing your skin. Therefore, it's essential to follow the manufacturer's recommendations and the company's safety program guidelines for replacement based on permeation times. A glove that protects for 30 minutes against one acid may not protect for 5 minutes against another. For electrical gloves, maintenance is even more rigorous. NFPA 70E requires visual inspections before each use, air tests to check for holes, and periodic dielectric tests in specialized laboratories. A damaged electrical glove is a useless and extremely dangerous glove. Glove cleaning is also an important point. Some gloves can be washed and reused, but it's necessary to follow the manufacturer's instructions to avoid compromising their protective properties. Others, especially disposable ones or those contaminated with hazardous substances, must be disposed of safely and environmentally responsibly. The safety of your hands and the environment depends on it. In addition to everything we've already discussed, OSHA and good safety practices make us think about some super important additional considerations that are often overlooked. Fit. Gloves that don't fit correctly are a danger. Gloves that are too large can get caught in moving machinery, causing serious accidents. They can also reduce dexterity, leading to errors and frustration. Gloves that are too small can tear easily, restrict movement, cause fatigue, and even circulatory problems. The glove needs to be like a second skin, allowing you to work comfortably, dexterously, and safely. OSHA emphasizes that PPE must be of appropriate size and fit. Dexterity and ergonomics. In some tasks, dexterity is crucial. OSHA understands that it's necessary to balance the need for protection with the ability to perform the job. Gloves that are too thick or rigid can hinder tasks requiring fine touch or manipulation of small objects. Sometimes this means using thinner but highly resistant gloves thanks to advanced materials, or gloves with specific coatings on the fingertips to improve grip and tactile feel. The ergonomics of the glove are vital for worker comfort and acceptance. Personal hygiene. Finally, but no less important, personal hygiene. Washing hands before and after wearing gloves is fundamental. This prevents cross-contamination, transferring substances from the glove to the skin or to other surfaces, and ensures that even with gloves, your hands are always clean and safe. If the glove has been used for chemical or biological protection, hand washing after removal is even more critical. Allergies. As I mentioned, OSHA requires employers to consider alternatives for workers with latex allergies. Nitrile is an excellent option in these cases. Comfort and acceptance. A glove that is not comfortable or that interferes too much with the task has a high probability of not being used. OSHA, although it doesn't dictate comfort, indirectly promotes it by requiring that PPE be adequate and that workers be trained to use it. A worker who feels comfortable and safe is a more productive worker and less prone to accidents. OSHA and ANSI ISEA 105 are not there to make our lives difficult, but to protect us. Their standards are the result of years of study, research, and unfortunately, many accidents that could have been avoided. They are a robust guide for employers and workers to build a safer environment where our hands, these precious tools, are always protected. So, everyone, the next time you're about to get your hands on a task that presents a risk, stop and think, am I wearing the right glove? Is it in good condition? Do I know how to use it and when to change it? Remember OSHA's guidelines and the classifications of ANSI ISEA 105. Our hands are too valuable to be neglected. They allow us to work, create, care, and interact with the world. Protecting them is protecting our ability to live fully. Safety is everyone's responsibility. If you're an employer, ensure your hand protection program aligns with OSHA and the best practices of ANSI ISEA 105 and NFPA 70E. Invest in training and the correct gloves. If you're a worker, demand and use the correct PPE. Your life and your health depend on it. I hope this video has been useful and has shed light on the importance of hand protection and the complexity behind safety standards. If you liked it, leave a like, share it with your co-workers, and subscribe to the channel for more safety content. Leave your experiences and questions about glove use in the comments. I'd love to read and interact with you. Until next time, and stay safe.